All right. Avail projects. This is very exciting. It's defined as a unification layer, but for what I see, it's more like unification several layers. What exactly is Avail, and what are all these layers that you talk about?
Yeah, I love the multiple layers. But if you think about at the end of the day, we built this really cool thing called a blockchain. And within one of those blockchains, there's like a bunch of components. There is the transactions, how they're ordered, then there's the execution side, then there's the nodes and the consensus, and then there's the scripting language. And, for the last 10 years, we've been fighting around exactly what this all looks and feels like, and people have preferences and opinions. And at the end of the day, what we're really interested in seeing is useful applications built on top of them. So DeFi is a great example of this. Now, what do we need for fundamental part of the blockchain? One is what we call a data availability layer, which is the first product that we launched on Tuesday. Very excited about that. Data availability is a very simple concept of taking all the transaction data and posting them somewhere where you can verify that you can construct the same sets of transactions without having to store that data, without having to worry too much about your nodes having access to that data. And that's an important part for scalability and modularity. So we're in essence breaking up the execution and the data availability side. So that's the layer one.
All right. Let me separate here for a second. So how would this, so you mentioned this modular approach, right? Can you sort of draw a parallelism with a non-modular blockchain, like would be Ethereum or Bitcoin? What is the data availability part of these non-modular blockchains?
Yeah, because they're non-modular, they're basically built into the node operating system. So if you run an Ethereum node or a Bitcoin node right now, you'll not only have to rerun all the transactions and process those transactions, i.e. execute those transactions, you would also have to store every single bit of the data that makes up those transactions. And also specifically for MEV purposes, the order at which the transactions are executed, because that's really, really important. So fundamentally what we're saying is, the computation that you want to do, you can use the Ethereum virtual machine, a ZK virtual machine, the Bitcoin machine, or whatever it is. It's not exactly a virtual machine, but the computational scripts that you can process in Bitcoin, all of that you can do, absolutely, and focus very highly on that. And what we will say from our side is we'll take care of storing those transactions in the order that they were sent to us, so that you can then rerun that computation from your execution environment whenever you choose.
All right, so that's to draws sort of parallelism. It's as if if Ethereum, for example, had a light client, you can decide to point at another node which keeps the data and say hey, can you rerun this transaction for me, whether it's valid or not? And there's some sort of proof that the node is serving you the right information to this light client.
That is exactly it.
Okay, perfect. All right, very clear. So I'll let you move on to the next modules or layers. Thank you.
Yeah. And now that we've got this modular stack component that's quite interesting to see what you can build out of it. Now, the Ethereum ecosystem decided that they were going to be building their scalability solution using the L2 concept. Bitcoin chose Lightning. Various other ecosystems chose their own paths. So what does that mean for us when we're building out this L2 ecosystem? one of the biggest problems that you'll see now and today is this idea of fragmentation. So ecosystems are siloed, they are built in different ways, they have different communities, they're built for different purposes. And that's totally fine, that definitely scales the solutions, but there are certain like economies of scale when you can work together. Good examples of this are liquidity. If you want to run a liquid exchange like a DEX, you would end up having to fragment that liquidity, which is bad on a per case basis. But if you have to aggregate all that liquidity into one space, then it's great. But then you have this siloed effect. So what we traded off for scalability, one of the features that we got was fragmentation. Now, fragmentation is it's probably the biggest solution space that people are trying to fix at this point in time, and Avail is no different. Our approach right now is to build on top of that data availability layer the idea of asynchronous composability. So what does that mean? It just means that you can do an action in one chain and have the output of that action be executed on another chain. The product that does this is a product that we're calling Nexus. And what it basically is a ZK proof intent protocol that allows you to express how you would like your outcome to happen. Some solvers will execute that, and we verify that those executions happen through ZK proofs. And then the Nexus protocol is the aggregate of all those proofs. And you can end up being able to say, for example, mint an NFT on Arbitrum, but the fund that you use to do the mint are on Optimism, and you can have that transaction look and feel like it's been one transaction. We can do this quite interestingly, more efficiently because of the shared DA layers that we'll have. And so the way that like that base layer of data availability exists today allows us to build more powerful composability components on top of that.
All right. How does these so blockchains are stateful? They have a certain state. And you seem to be referring to. I'm trying to wrap my head around the idea because I think the parallelisms with Ethereum and Bitcoin just end here, right? In order to have one token and not being able to double spend it in different rollups and different stuff, we can be taking from the same data availability and to read the state, and then we can use that state from whatever other rollup we spin up within the Avail ecosystem. Is that how it works?
Yeah, let me run through a very simple example that I think everyone's done. So, Lansky, you're on Arbitrum and I'm on Optimism. What we want to do right now is I want to send you 1 ETH for saying thanks for being on this podcast. For me to do that, I would have to bridge that asset, go onto the bridging website, press F, reload 500 times. Remember that there's a trust assumption on this bridge. Press F5 500 times, waiting for the deposit to reflect in my Optimism account, and then really just like enjoy the frustration of that experience, and then send you the funds once it's arrived. And then that's like how we would do that transaction in today's world. There are other solutions out there that can do this in a bit more of a seamless way, but they're also nascent, just like the Nexus product is. What we're thinking about here is something slightly different to that process. So what you can do is create an intent, and if anyone who doesn't know what an intent is, it's simply just an expression of the outcome that you want. So blockchains are really good at taking inputs, they process those inputs, and then they give you a deterministic output. That's how Ethereum works, that's how Bitcoin works. Everyone is really good with that. So What intents are is a slightly different approach where you can express the outcome that you want, but not necessarily care too much about those inputs. So humans, for a large in part of our like communication work through intent-based communication, I want this to happen, and you don't really care how it happens. You just want it to happen. Food delivery is a great example. I want my burger or my pizza. I don't really care how the restaurant delivers it to me. I just care that it gets delivered. So, there's a lot of that you can abstract. You just want the outcome. So I want the expression in the example that I used earlier is I want to send this one Ethereum and I'm going to send it from one chain to another chain. So the constraints here are the different chains, and I don't necessarily care what bridge you use, and how you go about it. I just want that outcome to happen. So in this state, we have a pre-state and an end state, and so and on two different chains. So on chain one, my chain, I'm going to express this outcome and send it to an intent-based network. This intent-based network is going to resolve that outcome, i.e. do the send and perform that action. And then we can verify that that action was indeed done correctly by creating a proof on the other state. Now, what Nexus will be is the process for where those two proofs can aggregate and ensure that the actual outcome was achieved.
All right, amazing. We have a question from Felix.
Hey guys.
Go ahead.
Hey, great talk so far. Just wanted to really quickly ask, I'm just interested. So when we're talking about intents, right, you have to be able to determine what can even be an intent. So how do you determine that? Do you basically know in advance, hey, this is what's available on every single of the networks, right? How do you aggregate what a person can do, for example, between two networks? How do you determine that essentially? How does one register for that?
Yeah, so one of the most important parts of any intent network is what we call the solver network. Now, what the solver network is a group of bots coded up by engineers that will perform these actions, and they can only perform actions based on the rule set of a certain environment. So in the case of Nexus, there will be certain use cases that a person can do, and the solvers can do that and then prove that they actually did do that outcome. From a kind of computer science perspective, it's really hard to define all the types of intents that you can do. Just to engineer them will take forever. But what you can say is there are these 10 common use cases that will enable a lot of activity. So a good example here is bridging, swaps, borrowing or depositing, lending. The main functions that most of the chains have, mint NFT, you can build these trains out really easily and kind of build them into a certain set of instructions. That's fairly easy. It gets a little bit more complex, and I would argue impossible if you start kind of describing it, very lackadaisically and having 100 different steps in that process. I don't think that these solvers are geared up for that. Another way to think about it is to ask for a food delivery service from a different city and then ask it to go on a train and then a plane and then a bus and then a car. That might sound a little bit silly, but asking for food delivery from my local place and just having a bike driver or a car driver deliver it, that's easy to recognize. So in the case here, the simpler these intents are, the easier they are to actually resolve.
Yeah, absolutely. I got you. And the question then is, so Nexus decides on what the possible intents are going to be at this point, right? So, for example, if I want to create a new type of intent, I would actually first have to talk with you guys, right? And then be able to achieve that on the network itself.
Yes, that will eventually be how the system will work, although the actual specifics on how we would want people to build these intent networks are, and what types of intents will be supported are TBD, and these are parameters on how the network will grow and what it can support. In terms of how the architecture is designed, that's set, but the interactions within that architecture still need to be ironed out, and that's why this layer 2 product that we're building isn't live yet.
Oh, absolutely. Yeah, super cool. And one more question before I leave the stage and maybe jump in later if I feel like it. So right now, you're gearing mostly towards EVM networks, right?
Not really, actually. EVM is one that we'll support. So currently we support all the EVM type chains. So your super chains, your orbit chains. We're also going to be supporting in the other ecosystems as well. So your Bitcoin network, your Bitcoin L2 networks that's going to be coming online fairly soon. We'll also be supporting the Cosmos ecosystem, Solana, basically any chain the Avail ecosystem can support, and we'll prioritize creating that support due to demand and what we're seeing as what people are wanting to build towards. So day one, Optimism, Arbitrum, those two stacks work perfectly. We're also going to be working, one of the ones to mention is the ZK EVM, so your hyperchains from ZK Sync, Scroll, Aztec, Starkware, all those chains are fundamentally going to be supported within the Avail ecosystem. We want to be chain agnostic as possible.
All right, super cool. Thanks a lot. Gonna hop off the stage.
Thanks for you, Felix. For amazing questions. I guess that brings us to the last layer, Fusion.
Yeah. So Fusion. The best way to kind of say what Fusion is that people will immediately understand, it's eigenlayer. It will fundamentally be an eigenlayer competitor with a different approach. Naturally, we can't exactly just copy that concept and be done with it. There are a few differences. So one, we're going to be multi-collateral. So we can accept Bitcoin, we can accept Ethereum, and we can accept other types of tokens. This is actually kind of important distinction because economic security doesn't necessarily have to be the base token. It can be other types of tokens. And if you're an app chain, how do you create that economic security if you don't have your own token? It's going to be really hard. So that's the one difference. The second fundamental difference, and it's the one that I'm kind of a bit more excited about, is the approach that we're taking. So to say economic security is great, but what are you securing? You're securing the transactions on the network and having some sort of mechanism to ensure that there's honesty within the network. And that's important, right? Honesty within that network is predicated on the value being transferred within that network. And if you look at what Eigenlayer did, they built an entire a huge bank of economic security without the actual network. Whereas what we're trying to do is, and through our approach, is build the data availability layer, then that interop layer, and then when we're adding that last layer, which is this economic security layer, we know exactly how much economic security this network needs, and therefore the approach, the scalability of that operation can be kind of a bit more organic and not necessarily huge. So yeah, I think that the Fusion approach will also have a couple other extra features that we can't exactly announce yet, but a little bit of alpha is that the idea of shared economic security amongst economic security participants is an interesting overlap. So, you can't have one team own all economic security. You can have multiple teams. And how do we aggregate that economic security that it's kind of like an interaction between multiple silos is a part that we're very interested in working on, and like at a very high level, and that's the truest definition that we could have on unification.
Right. It does sound fairly high level, and but it's not online yet. You just released Avail DA on Tuesday. Congratulations for this. When can we expect Nexus and Fusion to be online?
The famous when question. So Nexus is next on our roadmap. It will come fairly soon. I can't set a specific date, but within the course of months. Fusion was slated to come out sometime next year, but because of that little bit of interesting alpha that I shared, I can't be too specific on the details. That might come a little bit sooner than expected. So maybe this year in the timeline. Wink, wink.
Gotcha. Nice. That's some alpha right there. Okay. One more thing. You've touched basically on the triad of infrastructure: data availability, ZK intent, and then restaking, or also known or expressed as unified economic security. So we're recording this 2 weeks after EFCC, which is probably the biggest European conference on Ethereum. And one of the biggest feedback that was in the air, or one of the main takeaways of EFCC, is all of this infrastructure for what? What are we supporting? What, like, and I guess, like, translating this into the question for you, we have been working on rollups for a year. ZK, validity proofs, fraud proofs. There are many people already building infrastructure. Why? And nobody's really like using it for new innovative things. Why did you guys think that we needed a new approach?
Yeah. I had two very strong opposing thoughts on that exact question. And I love this question because, like, at the end of the day, everyone's building infra and there's zero apps. And the argument I would say for why that's the case is fundamentally that we have not solved scaling and we have not solved the user experience. A lot of work needs to happen in that. Like, I'm never going to do a dial-up connection to get on the internet ever again or to access a website. Why would I need to basically download a MetaMask extension, then upload a credit card before I even tried anything? Like, there's a lot of work that needs to go for the application layer for that to happen. And so I think a lot of really important teams are building in the space, and I would personally be very, very excited to support any of those teams moving forward. And then on the other side is I actually don't think we have enough infrastructure at all. Like, yes, we're building to very little demand, but we also haven't really solved much of the problem that we have with this ecosystem right now. And like, I think if you look at how much like interactions happen on the internet today versus what had happened, like, post the .com like bubble and then pre that, we're very early in on this innings of like what this technology can do. And if we truly believe that we're building a future of the internet for like the entire world, then that infrastructure definitely needs to be in place. And one of the areas that I'm quite excited about, like enabling from my personal viewpoints and what Avail's fundamentally being structured as, is to be this experimentation layer for people to be able to build their applications really cheaply. So if you are a you want to deploy a chain, you want to deploy a dApp, you want to deploy something on some infrastructure. Right now, it's extremely expensive to do that. But if we can bring that cost down, then we can get the more developers building interesting applications. They don't have to worry about the entire stack. They can just worry about their little like execution environments plus their like marketing and figuring out how they're going to solve real customer problems. So I actually think that, yes, lack of consumer apps, but also the infrastructure isn't quite there for people to deploy applications quickly and simply and easily. Like right now, if I wanted to build a Web 2 website, there's literally a one-click solution for me to do that. And all I get to do is design some pretty pictures for what the website's going to look like. We're not quite there yet for blockchains. And we're going to have to eventually get there. So I'm quite excited to work on it that layer at least.
Would you say that basically we might have built all of this infrastructure, but until it might not even be good infrastructure what we have so far. What we need in order to have more apps is infrastructure good enough that I can just jump in and build something without having to worry about which rollup I'm doing, which chain it is, whether there's going to be enough liquidity, whether there's going to be all of this is what's sort of hampering the appearance of good apps. The fact that there's no good way of unifying liquidity. There's all this. And when the infrastructure gets good enough, then is when all the apps. In a similar way than when Google's blogging system, I can't remember, I think it was called Blogger. I had like 3 of those and I can't remember the name already. But Blogger or WordPress, as soon as they made it stupid easy to create a blog, everybody started blogging. What you're saying is that as soon as we make it stupid easy for everybody to use blockchain in their games, all of the games are going to be using blockchain.
Yes, absolutely. And any team right now that wants to build in the blockchain space, it's probably the most expensive space to build an application outside of AI right now. But once that tooling becomes available and really easy to use, we'll have really smart and amazing entrepreneurs building really interesting things.
Gotcha. And with this take that our infrastructure sucks and we'll start getting apps as soon because the infrastructure empowers us to build these apps, we are going to continue seeing infrastructure projects coming in. Maybe, just maybe, Avail will be one of the last ones because you guys will solve this infrastructure problem. Ideally. I think this is a good place to leave it right here. Chandler, thank you so much for being so open, for answering so honestly and so expertly as well, for withstanding the barrage of questions of the dOrg hot suits. Thank you, Felix, for jumping in and putting your own interests and expertise as well onto the podcast. And is there any last mentions, any shields, any announcements that you want to bring, anywhere where you want to direct our listeners to?
Yeah, if you're building something really cool, I would love to talk to you. Please reach out to me. We can set up a call. Avail's DA availability solutions live right now, so we've got something that we can sell to you. This is also an opportunity for you to maybe explore some of our grant ecosystem. We're giving usage grants, so you get free data availability for whatever application that you want to use. It's actually quite a generous amount. We're also doing retroactive funding for any teams that build cool apps. So if you build a cool app, people use it, they love it. We'll give you some pretty awesome rewards. And then soon, not quite yet in place, but in the next coming weeks, we're also going to be setting up our ecosystem fund. This is a standard venture type investment arm for teams that are going to be building within the Avail ecosystem. So if you are entrepreneurial and have the spirit to build cool stuff, please reach out to me. I would love to talk to you and get get you funded enough to kind of build your awesome ideas.
Right on. Thank you very much, Chandler. This has been Avail project in the dOrg hot seat. Thank you, and we are off record. Chandler, thanks a lot. Seriously,
Thanks so much, man. That's great.
Yeah, no, absolutely. And thank you for the members who were here as well. Clara, Anita, being here on the recording side. Daniel, Santiago, and especially Felix for the amazing questions.
Yeah, that was good. I enjoyed that. Thanks,
yeah,
man.
definitely.
Hey, thanks for being able to follow my train of thought. I know I sometimes can be a bit less than less than clear my questions.
No worries, dude. I got with you. I picked up what you were putting down.
Cool. Hey, really great talk. Thanks a lot.
Same. Have an excellent rest of the day, everybody. Chandler, when it's live, we'll get in touch with you so you can retweet, repost, share it in your socials, and be able to use this material too. So hopefully that'll be very soon. We'll be in touch, and thanks again for coming.